All right. Good afternoon. I've had a student ask me about the the normal distribution rules, the 68, 95, 99.7 rule. So this is going to be a really dodgy diagram because it's, well, it is what it is. Now, if your data is normal distributed, if it's approximately normal, it should that is a really bad diagram. It should approximately look like that. It's also known as a bell curve. So this is a normal distribution or a bell curve. Now, the important thing to recognize is that if I have a normal distribution, this top bit here is going to be my mean. So this peak here, the absolute top of my bell curve is going to be my mean. So, for example, if we're talking about scores on exams, in an ideal world, you will have a mean of 50%. And you'll have a standard deviation of 15%. So a standard deviation of 15. In the case of my standard bell curve, what I can do is I can now go and I can mark. So if this is 50, then I can... Oh, I don't want to erase that. Why would I want to erase that? That's beautiful. If I want to count up from 50, and I want to go up a standard deviation, if this is 50, what's this one going to be? Well, it's going to be 65. If I want to go up one more, make sure they're approximately equidistant apart, 80, and then up again will be 95. And if I want to go down, I'm going to go down by 15s. So that's going to be 35, 20, and then 5. Obviously, this is imprecise because I'm using this and this damn thing. But the point will still make the point will still make sense. Now, I need my ruler again. This time I want a straight line because straight lines are useful to me right now. So what I'm going to do is I'm going to draw some straight lines. So in blue, I have drawn a line down my mean. And in blue, what this means is that I have 50% above and 50% below. Or 50 below and 50 above. What that also means is if I look one standard deviation from the mean, that means I go a standard deviation up and a standard deviation below. I'm going to do this in green. If I go a standard deviation up and a standard deviation below, so that's a standard deviation below, and this is a standard deviation up. The rule states that if you are within one standard deviation of the mean, then you are in 68% of your data. So if your data is normally distributed, 50% will be above the mean and 50% will be below the mean. But 68% will be between our two standard deviations, or between our one above and one below. So from here to here is going to be 68% of the data. Now, because this is symmetrical, this also tells me that this here is 34. And this is also 34%. So it's 34 above and 34 below. So a standard deviation, so 34% of my data should be a standard deviation, one between the mean and one standard deviation above. Now this is an ideal world example of math scores, for example. Now, where it gets a little bit more interesting is when I start adding in the extra lines. So one standard deviation is 34%. Now I'm going to put in a red line for two standard deviations. So that's a standard deviation. That's two above. Bloody tablet. Now, two standard deviations is a little different. Well, I say a little, I mean a lot different. Between two below and two above is 95% of my data. Between the two red lines should be 95% of my data. So when we do a maths exam or things like that, if the mean is 50 and the standard deviation is 15, then 95% of you should get between 80% and 20% in terms of a score, as a percentage. All right, 95% of you. That means only a few percent of you should get much worse or much higher than that. If 95% of my data is between 20 and 80, then the other 5% that make up the rest of my data should be outside of those two lines. And again, because it's a bell curve, it should be symmetrical. That means if I take that remaining 5%, if I take the remaining 5% in red, I should have 2.5% here and 2.5 bloody ruler's getting in my way again. 2.5% outside the line. And if we go back to the green for a second, the same logic will apply. 16% will be outside the line over here, and 16 above. All right, so we're taking our 50 and we're breaking it into chunks. All right, because the last one is the other interesting one. 3 standard deviations we're going to do in black. Three standard deviations, which is in black. 3 standard deviations, so between here all the way over to here, should be 99.7% of your data. 99.7% of your data should be between 5 and 95 based on that information that we've already given you. That means 0.15% should be there and 0.15% should be there. In an ideal world, that's what should happen. In an ideal world, you should get only 1 or 2 people getting nothing and 1 or 2 people getting higher than 95. In practice, that's usually we usually have what's called a reverse bell curve, where we get a lot of people who know nothing and a lot of people who know everything, and it's the opposite shape. Now, if you divide your diagram and you divide it the way that I've done it, what you can eventually work out is all of these little in-between pieces. So between this line and this line here, or this line and this line. And if you know the broad percentages that you're working with, you can work those out. So if 34% is between my blue and my green line, and 16% is below all of that, what is between this line here and this line here? Well, if 2.5% is from here all the way down to here, then what's in here should be 16 minus 2.5. And I'm going to do this, I'm just going to do this in black for the sake of my sanity. It's going to be, so between here and here should be 13.5. And because, again, symmetry is important, that's also the case over here. So that means between here, and here should be 2.5 minus that 0.15 at the end there. So that's going to be 2.35. Therefore, over here should also be 2.35%. So if I take that and I add that and that and that, I should end up with my 50%. If I add up all the percentages, I should get back to my 50 somehow. All right. What that means, is that depending on the information that you are given, so for example, I could say, what percentage of students got between 20 and 65? So 20, what percentage got between 20 and 65? Well, I know that 20 to 35 is 13.5%. I know that 35 to 65 is 68%. If I add those two together, then I end up with 81.5%. If I wanted 65 to 95, so if I wanted 65 to 95, well, 65 to 80 is 13.5, and I know that 80 to 95 is 2.35. That means the answer should be 15.85%. All right. By splitting the diagram up, we can make it easier to do these sort of calculations.